Welcome back. So today I want to spend a little bit of time on graphing cubic functions and be able to find that critical information using our technology. I highly recommend that you use the 83 or the 84 calculator, as those are going to be the calculators of choice as you get into college and your upper level mathematics. So we've talked relative and absolute maximums and minimums and increasing decreasing intervals and end behavior and our domains and our ranges and zero solutions roots from our quadratics. We're going to do the same thing with our cubics. We're just going to notice that our cubic function is going to be have a little more information with it. So the first thing we're going to do is go ahead and put this equation into our calculator. So I'm going to go to my y equals. I'm going to type in my x to the third. So I'm going to do x to the third, and then plus 6x squared, plus our 5x, and then minus 1. So if you don't remember that x, we can hit just the x button next to our alpha button to get our x value. I'm going to go ahead and change my windows to make sure that they are set on a normal window. And what you can do is if you hit zoom, you can do a standard window with number 6. And that'll give us a graph of what we have here. And notice this graph comes up, and it comes down, and it comes back up. We can't see a whole lot of that graph up here. So what we can do is we can change that window, and we want to change that y height. So if I come over here and I change my y max, instead of maybe at 10, if I set it at 20, and I hit my graph button, now I can see my graph. So I'm going to start low here, I'm going to come up, come down, a little dip, and then go up. So the first thing I'm going to talk about is our domain. So the domain of this function, so if I wanted to graph this entire function, notice this branch here, this is going to come down forever and ever and ever, and it's going to come out. This part here is coming up, and it's going to continue to go up forever and ever and ever, and we're going to work its way out. So our domain for this function is negative infinity to infinity. My range, I look at the y values. Again, this is going to continue down forever, so I'll hit negative infinity on the y-axis. As I work my way up, I'll always be able to touch this graph, and it'll go up until I hit infinity. So my range is going to be negative infinity to infinity. My maximum. Notice I have a relative maximum at this point. And what a relative maximum means is that in this region, in a small region, I hit a high point. It's not our absolute maximum, because I know our absolute maximum was way up here. So we call it a relative maximum. And that point, to be able to find that point, that high point, what we're going to do is we're going to do second trace, and we're going to find our maximum point. So we're going to hit number 4. Notice a cursor pops up, and your cursor may be different than mine in a different location. But what I want is I want that cursor to be over in this region, so to the left of that high point. Notice it says left bound. So we can do that one of two ways. We can move that cursor over by using the left arrow. Notice how it moves it across there. Or I can type in a number. It looks to me, looks like we got 1, 2, 3, around -3. So if I type in -4 and hit enter, that'll move the cursor to -4 on the x-axis, or the x value. Now I can go ahead and go to my right bound. Again, I want to move that cursor to the right of that point. So again, I can hit my right button, or I can type in a number to the right of it. Again, I thought it looked like maybe -3-ish, -3.5 maybe. So if I type in -2, that would work, or I have -2.3, that works as well. I hit enter, and then it asks us to guess. Guessing here, you could just go ahead and hit enter, or you can move that cursor to where you kind of think it's going to be. And if you hit enter there, and that's going to give us our maximum value. Our maximum value is -3.527524, on and on and on. What I'm going to be looking for is that we round or truncate to 3 decimal places. Very important that we go to 3 decimal places as we get into our upper level mathematics. So our relative maximum is going to occur at -3.52 Truncating means that we're just going to cut it off to 3.527, or we can round it. If we round it, that 7 could be an 8. And then our y value is going to be 12.128. This one would not round, so we would leave it as just 12.128. And that would be our relative maximum. While we're doing it, I'm going to go ahead and jump over here to do our relative minimum, our minimum value. Notice our minimum value here is going to occur in this trough. It's not our absolute minimum because this branch here, this part of this graph, goes down forever. So to find that minimum, I'm going to again second trace, and we have a minimum value, so we can type in 3. Again, left bound. It looks like, to me, it looks like it's about 1/2 or -1/2. So I'm going to type in -1. I think it's a little easier to type in numbers. A number to the right of that looks like 0 would be to the right of that. And I'm going to move my cursor just a little bit. Again, you don't have to. You can just go ahead and type it in. So again, we have a relative minimum. It's not an absolute because we can go lower than this. But just in that region, it's a negative or a minimum value. So a relative minimum at -0.472. Again, 3 decimal places, rounding or truncating. And in our y value, we get -2.128. And that's going to be our relative minimum. Again, there is no absolute maximum or minimum for this function. Our end behavior, that tells us what's happening at the ends of these. So we're starting on the low end and we're ending on the high. So using my arrows, I can use my down and then my up. So that tells us that the first part of the left side ends low or starts low, and our last point tells us that we end high. Solution, zeros, and roots. What do we know about solutions, zeros, and roots? Yes, they are where we cross the x-axis. So we can again do a second trace, and we have zeros for us. So number 2, again we have to do a left bound, so we want to be to the left of this value here. So again, we got -1, 2, 3, 4. It looks to me like it's -5. So I'm going to go ahead and type in -6 for my left. I want a number to the right of that value, so I'm going to say -4. And I'm going to guess, hit enter. Interesting value there, isn't it? -4.948826. And let's look at this y value. Y equals 2e to the -12th. What does that mean? That might be the first time some of us have come across that. That e and then 12 means times 10 to that -12th. Well, what is that value? Remember, if we take 10 to the -12th, we're going to move that decimal place 12 places to the left. So we're going to have 11 zeros and then a 2. So what do we think about that big, actually the small number? It's pretty close to 0, isn't it? So we have to recognize that when our calculator gives us something like this, that's really just going to give us a 0 value. So we're going to have x equals -4.94. Again, we're going to 3 decimal places. We can either round or truncate. So it's going to be truncated in an 8, or you can say -4.949. Again, rounding or truncating to 3 decimal places. We also have another one. It looks to me like we have one at -1. So we're going to do the same process. Second, calculate. We're going to find that 0. So number 2. Again, I want to be to the left of it, so I'm going to type in, say -2. It looks like 0 would be to the right of that. Hitting enter, I get a -1.217. Again, to 3 decimal places, we're not going to be able to round that because the next number would be a 1. Looks like we have another one pretty close to right after 0 there, just to the right of 0. So I'm going to second trace. I'm going to do my zeros. This time I'm going to type in 0 for my left bound. My right, I'm going to type in 1. Hit enter for my guess, and I get 0.166 and then 0, so that's not going to round. That 6 is going to stay at 6. So those are my solutions, my roots, and my zeros. The last thing we're going to talk about is increasing and decreasing intervals. So where is this increasing? Well, again, we're talking about the x values when we increase, and we're going to start at negative infinity because this thing is coming up, negative infinity all the way to this x value of this high point. So we're going to say negative infinity. Well, what is that value? Remember, that came from our relative minimum. And our relative minimum was at negative 0.472 and then this 2.128. So we have the x value at 0.472. And that's going to be at a parenthesis. But notice also we have another increasing interval. We start at this low point and we go high as well. So we're going to put a U, which means union. We're going to pick it up again at this low point, that relative. Oh, I picked the wrong number, didn't I? Oh, my apologies. This x value is at the relative maximum, isn't it? So negative 3.52. You thought you were going to get some extra credit, and I caught myself. So, keeping going, relative minimum. So we started this relative minimum, and we're going to continue out to infinity because this is going to come up forever. So our union negative here comes in our 0.472 to infinity. Our decreasing intervals, again, we're looking at this x value, so this negative 3.527 to this minimum value, negative 0.472. So our decreasing intervals, negative 3.527 to negative 0.472, again in parentheses. So notice our increasing and decreasing intervals, we can work from negative infinity all the way to positive infinity with our numbers. So we have negative infinity to negative 3.527. Then we pick up our negative 3.527 to negative 0.472. And then we pick up our 0.472 to infinity. So that's going to give us an idea of what our graph is going to look like. So that's a little on the lengthy side, but hopefully that makes sense to you. You can go back and you can review any of those topics that you need to, or you can join a Zoom, or you can send me an email and ask a question. So good luck, enjoy, and I hope it works out for you.